All right, here we go. 10.5, independent and dependent events. First, let's take a look at what the difference between an independent and a dependent event is. So, independent events, those are events. Events are independent events if the occurrence of one event does not affect the likelihood that the other event will occur. So these do not affect each other. Think about it. If you're independent, right? You're not affecting anybody else. You're on your own. You're working by yourself, right? You have no effect on anyone else. Whereas dependent events, you're dependent on someone else or something else. So events are dependent if the occurrence of one event does affect the likelihood that the other events will occur. So when we're looking at the probability of each, so probability of independent events, they stand alone. You find the probability of the first event, multiply it by the probability of the second event. They're not affecting each other. You find their separate probabilities and multiply. Whereas when there's dependent events, you have to find the probability of the first event. Once that event happens, the probability of the second event is going to be changed. So you'll find it after the first event has happened, and then you'll multiply them together. I think showing you and doing some examples will help. So let's take a look. First one, you spin the spinner and flip the coin. So if I spin the spinner and flip a coin, you're thinking, are these independent events or do they depend on each other's results? So if I spin that spinner, is that going to affect whether my coin lands on heads or tails? No. So these are independent events. It doesn't matter what I get on the spinner. It's not going to change whether or not my coin can land on heads or tails. So now I want to know, what's the probability of spinning a prime number and flipping tails? So we have to first find the probability of each event. So the probability of spinning a prime number. Well, let's take a look at our spinner. If you know what a prime number is, great. If you don't, I'm going to explain it real quick. Prime number is a number that is the only products are itself and 1. So like 2, there's no other factors besides 2 and 1, so that's prime. 3, the only factors are 3 and 1, so it's prime. And 5, the only factors of 5 are 5 and 1. Whereas 4 is not prime because it has 4 and 1, but it also has 2 and 2, okay? And then 1 isn't prime or anything, we don't count that. So probability of spinning a prime number, there's 3 out of the possible 5. And then what's the probability of flipping tails? Well, there's only 1 tail out of our heads and tails out of the 2 probabilities. So now to find the probability that both events are happening. So again, there's 2 things happening. These are compounds. So now we're going to multiply them. So multiply 3/5 by 1/2. We get 3/10. And that's our answer. Let's take a look to the right. People are randomly chosen to be a game show contestant from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What's the probability that one of your relatives is chosen first and then one of your friends is chosen second? So we want your relative or family to be chosen first and then a friend to be chosen. Now think about these 2 events happening. Does the first event, choosing a family member, affect choosing a friend? Now think about that. If you're choosing from a group of people, if you choose one of them, does the probability change when you go to choose another person? Hopefully you're thinking, yes, it does. And these are dependent events. Or I guess I should be circling that. Because when you choose that first person out of 100 people, right, you chose them, so you can't choose them again. You took them out of the group. So there's no longer 100 people to choose from. You now only have 99 people to choose from. So when you go to choose a friend second, you're only choosing from 99, not 100. So these events depend on one another. Does that make sense? I hope. So now what you have to do is you have to find the probability of each event happening. So the probability of choosing a relative, well, how many relatives do you have in the audience? 5 out of the 100 people, which we can simplify to 1 out of 20. Now, when you go to choose your friend, you still have 6 friends because none of your friends got chosen yet. But there's no longer 100 people in the audience. There's only 99. And I'm going to simplify this to 2 out of 33. Now I want to know the probability of both events happening, so we have to multiply these together. So I'm going to multiply 2 over 33 times 1 out of 20. Might be easier. Let me change this a little bit for us. 2 out of 33. I'm going to cross simplify. Let's change my color again. 1, 10. I get 1 out of 33 times 10 gives me 330. So the probability of first choosing a relative and then choosing a friend from the audience is a 1 out of 330 chance. All right. Last example here. A student randomly chooses the answers for each of the multiple choice questions. What's the probability of answering all 3 questions correctly? So if you take a look at this, multiple choice, each question has A, B, C, D, or E as an answer. So for each problem, you have 5 choices. Now, out of those 5 choices, how many choices are the correct answer? Only 1. So the probability that you get, so what's the probability of answering all 3 questions correctly? Well, the probability of getting number 1 correct, you only have a 1 out of 5 chance. How about the probability of getting number 2 correct? Again, you only have a 1 out of 5 chance. And the probability of getting number 3 correct, you have a 1 out of 5 chance. So what's the probability that you get all 3 correct? Well, you have to multiply all of your probabilities together. You have a 1 out of 125 chance of getting those 3 problems correct. There's only one way to do it out of 125 different combinations. And that's it. That is